You are welcome to Eko Learners Support for WAEC and NECO candidates. Mathematics class. Here we are going to be looking at something interesting today.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So in this class, we are looking at trigonometric ratios. Let's start with our learning objectives. By the end of today's class, we should be able to state trigonometrical ratios, that is the sine, cosine, and tangent, and apply trigonometrical ratios to solve right angle triangles. What is trigonometrical ratio? Let's start from there. First, we need to understand what trigonometry means. It is that branch of mathematics that deals with the relationship between sides and angle of right angle triangles. Now, from the word trig, that's three angles, metry, so measure of three angles. Trigonometrical ratios are the ratios of the length of side of a right angle triangle. The ratio that tells us the relationship between two sides of a right angle triangle. So let's take a look at this. We have this, a right angle triangle. Don't forget some parts of the right angle triangle. The longest side is what we call the hypotenuse. That is the side that is facing angle 90. The adjacent side and the opposite side can be interchanged depending on which angle you are discussing. But don't forget, hypotenuse remains the longest side of a right angle triangle. Now that we understand this, the ratio of these sides to each other to get angle is what trigonometric ratios is all about. We shall look at the three major trigonometric ratios, which are the sine, the cosine, and the tangent. There are more than that because we have the cot, we have the cosec, and more than that, cosh and the likes for advanced class. But here we are focusing on the three major trig ratios, which are the sine, the cosine, and the tangent. So let's consider this right angle triangle where we have angle A, angle B, which is the right angle there, angle 90 degree, and angle C. So we want to look at the trigonometric ratio, the sine, the cosine, and the tangent. Their relationship with the sides. We have the side A, which is facing angle A, side B facing angle B, and side C. So trigonometric ratio expresses the relationship between two sides. For sine, it is the ratio of opposite side to the hypotenuse side. For the cos, it is the ratio of adjacent side to the hypotenuse side. While tan is the ratio of opposite side to the adjacent side. So for the three main ratios that we have here, trigonometric ratio, let's now begin to look at it for it. If we follow this, if we are dealing with angle A, so the side facing angle A is the opposite side and the hypotenuse remains the longest side. So sine A will be opposite, which is A, that is the side A over the side B. If it is cos A that we are interested in, the cosine A will be adjacent. At that point, C will become the adjacent, while the hypotenuse remains side B. And for tan A, that will be opposite to the side of adjacent. Remember we said it, that the opposite and adjacent side can interchange depending on the angle we are considering. But the hypotenuse side remains the hypotenuse side. It's the side that is facing 90 degrees. So let's move on. From this triangle now, sine A, following this, opposite divided by hypotenuse. So the opposite by hypotenuse. So sine of a particular angle in a right angle triangle expresses the ratio of opposite side to the hypotenuse side, while the cos of A expresses the ratio of adjacent side to the hypotenuse side, and tan A expresses the ratio of opposite side to adjacent side, that is TOA. Opposite to adjacent, while cos is adjacent to hypotenuse. For A, now if you are looking at it from from C, if C is our angle of reference, then side C takes the place of opposite, while side A takes the place of adjacent. So for sine C, which is opposite to hypotenuse, that means sine C will be side C over side B. If it is cos C that we are interested in, cos of angle C is going to be adjacent, which is A over B, which is the hypotenuse. If it is tan C, it's going to be the ratio of side C to side A. And that is basic understanding of trigonometric ratio. Sine opposite to hypotenuse, cos adjacent to hypotenuse, and tan is opposite to adjacent. And understanding of this is what we minimize in mathematics to what we call SOH CAH TOA. You must have heard that acronym, SOH CAH TOA. If you have learned that, let's look at it. SOH CAH TOA. So when you are dealing with the sine of angle, the sine of an angle tells us the ratio of opposite side to the hypotenuse side. The cos of an angle gives us the ratio of adjacent side to the hypotenuse side, while the tan of an angle gives us the ratio of opposite side to the adjacent side. Yes, you find that interesting. All right, so let's take a few examples to master the concept of trigonometric ratio. We have this problem. Calculate to the nearest degree the size of the lettered angles in the figure below. So we want to find to the nearest degree the size of this angle. Look at this. This is a right angle triangle. We have the hypotenuse side given to us. Then how can we name this side? Remember, this is the angle of consideration. So the one that faces the angle of consideration becomes our opposite. So this is our opposite, this is our hypotenuse, and this is our adjacent. Now we have opposite and hypotenuse. So which of the trig ratio would you consider? Yes, SOH CAH TOA. Opposite hypotenuse. Fantastic. Sine. We are using sine. So here is going to be sine theta equals opposite divided by the hypotenuse. And that becomes our opposite, which is 6 divided by 15. So if we are to take this now, 6 divided by 15, maybe you can further express this as 2 divided by 5. So we have 0 point, in 20 that's 4. So sine theta equals 0.4. Remember, we are interested in the angle, not sine of the angle. So we then make use of our calculator to say theta equals the sine inverse, which is similar to dividing both sides by sine. So it becomes sine inverse of 0.4. So this we can check using our calculator. Sine inverse of 0.4, it gives us 23.578, 23.578 degrees. However, the question says to the nearest degree. We then have to approximate this. To the nearest degree, it becomes 24 degrees. So that is the angle of theta using trigonometric ratio. Remember? SOH CAH TOA. Let's look at the second question. For the second question, we are looking for the angle beta here. Remember, the longest side is the hypotenuse, which means it's not given to us. However, we are giving this side facing the needed angle, which is the opposite and the adjacent. So when you have opposite side and the adjacent side, what do? Yes, think about it. Which trigonometric ratio combines opposite and adjacent? Good. Tan theta. That means tan of what we have is equals to opposite over adjacent. So tangent expresses the ratio of opposite to adjacent, which means 6 divided by 8. And if we go on with this, our 6 divided by 8, so you can say 2 goes here, 3, 2 goes here, 4, which is 3 over 4. When you divide that, you get 0. So this one in 30, what do we have? 4 goes in 30. How many times? That's about 7. That's 0.7. So we are left with 2, and that's 4 goes in, that's 0.75. Now, that's our tan beta. But our interest is to find the angle beta itself. So we take the tan inverse of this. That means the beta will be equals to tan inverse of 0.75, which if we use our calculator, your scientific calculator, press shift then the tan side. So shift tan 0.75, that gives us 36.86 degrees. And remember, the question says to the nearest degree. So to the nearest degree, we are going to have this approximate to 37 degrees. So we've been able to solve this problem using our understanding of trigonometric ratio. Good. Look at this. Take a few minutes on this. Calculate to two significant the value of the lettered side. In our last example, we dealt with how to determine the angle given two sides. But here, how can we determine sides given one angle and one side? So that's the situation we find ourselves here. We are to find the value of x and y given this angle and the hypotenuse side. To start with, we must know that side x is the opposite to the given angle, and side y is the adjacent to the given angle, while the hypotenuse is given to us. So which of the trig ratio combines opposite and hypotenuse? Great. Sine. That means we'll say sine theta equals opposite to hypotenuse, which then means sine 35 degrees equals the opposite is x over 20. So here we multiply 20 by both sides, then we'll be left with 20 multiplied by sine 35 equals x. So if we take it beyond this, that will give us 20 multiplied by sine of 35 using our calculator or 4-figure table. We have sine 35, that gives us 0.5735. If you check 4-figure table or use your calculator, you get approximated value of 0.5735. So 0.5735 equals x. Then we multiply this by 20 to give us 11.47 equals x. Because we are dealing with two significant figures, so remember, this is two decimal places and not two significant figures. If it were to be two significant figures, how do we express it? Students often find this confusing. Significant figure. So you approximate it totally. X is approximately 11 to 2 significant figure. This is 1 significant, 2 significant. This is becoming 3 significant, 4 significant. So here we approximate it to 2 significant figure. Now that that has been done, to get the value of y, combining hypotenuse and the adjacent. Hypotenuse and adjacent. The first thing that should come to your mind when you are troubled with which one combines it, just go back to your SOH CAH TOA. So we are looking for adjacent and hypotenuse. That's CAH, cos. Good. So to solve this, that means cos 35 equals the adjacent, which is y, divided by hypotenuse, which is 20. Wait. Oh, I've gotten x. Why can't I combine x and y? Yes, you can do that. But in mathematics, when you have option, it is advisable that you use the given figure, not your calculated figure. If there is no option of this given figure, I have to move on with my calculated figure. But when given other choice, please use that. Should in case there is a mistake in your first calculation, you don't continue transferring that mistake to another calculation, which can make you lose marks in your WAEC or NECO exam. So here now, we multiply both sides by 20 again. That becomes 20 multiplied by cos 35 equals y. So using our calculator, 20 multiplied by cos 35, that gives us 0.8191. So we then multiply this with 20. That becomes 16.38. I want to believe that that's the same thing you've gotten at your hand there. Again, to make these two significant figures, you already know what to do. Y is approximately, the significant figure will be 1, 2. What follows here is not up to 5 that we can approximate. So when you approximate a number less than 5, it gives you 0. So we then have 16 as it. ends. We can say y equals 16 and x equals 11. Interesting. Now you've learned trigonometric ratio and the use of it on a right angle triangle.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So, students, I would advise that we look into the past questions, our booklets, our textbook around, and solve more exercise on this topic, trigonometric ratio. Thank you. So for more questions, suggestions, and comments, do well to send it in through our social media handles being displayed on your TV screen. Till we meet next time, keep learning mathematics.
Thank you.